Git, a distributed source control repository. I try to picture clusters of information as they move through the file system. Were the commit messages like history books? I kept dreaming of a repository I thought I'd never see. And then, one day, get real.
You're watching Get Real. I'm Olivier Lacan. This is level 3. We're going to talk about cloning and branching. So in level 2, we saw that Greg pushed the repository to GitHub, and now a new coworker called Jane needs to get those files. She will ask something like, where do I get those files? And Greg's going to simply say to her, just clone the repository. How do you do that? If you're using something like GitHub, you would go to the repository, get the URL that you saw for the repo. So you go back to your command line, type in git clone that URL, and it will create a local directory with that repository. It will be called the name that the repository was called. If you want to change that name to something else, you can say the same thing, git clone URL, and pass in a name like git demo. The first thing git clone does is download the repository. The second thing it does is create a remote called origin and point it to the URL we passed it to. We can check that by simply running git remote -v, and it would list all the remotes, so you will see origin and any URL that we passed it to. And finally, it will check out the initial branch, likely master, and set the branch right there, and set the head. So Jane is all set up, but she wants to start working on a feature. To do that, it's best to create a branch. So we're going to create a branch called cat. Git branch cat will create that branch. But if we check with git branch, we can see we're still on the master branch. To move to the cat branch, we're going to need to git checkout cat. When we're doing that, what we're actually doing is switching timelines. We're not in the master timeline anymore. We're on a different timeline. We can do whatever we want and then move back onto master whenever we need to. We're going to run this command right here, and what it does is create a cat.txt file, and inside of it put the word Schrödinger. Then we're going to add it to the stage, commit it, and just put a commit message like create quantum cat. And this commit will be added to our cat timeline, not to our master branch, but to our cat branch. If we run the ls command to list all the files in the current directory, we'll see that we have the readme.txt file that Greg created, and this cat.txt file we just created. Now if we move back to master using git checkout master and do the same command, we can't see any cat.txt file. It's not there, it does not exist in this timeline. Now if we run git log, same thing, no commit, that create quantum cat commit is not there. Just to make sure we're not crazy, if we move back to the cat branch and do the ls command again, the cat.txt file is still there, we're not crazy. So let's assume we're done with that feature branch now, the cat branch. We're going to go back to master, git checkout master, and now it's time to merge those two timelines. It sounds really fancy, but it's actually quite easy. Git merge cat. Now that we're on master, Git will merge the cat branch into it, and it will tell us that it fast forwarded. It will say fast forward. What does that mean? So when we create a branch and make one commit or several, and we do nothing on the other branch, it's very easy for Git to merge the cat branch back into master because nothing was modified on master in the meantime. And now that we're done, we can safely delete the cat branch by running git branch -d cat. And Git will show us that it actually did that. Our next assignment is to work on the admin features for our application. So we need to create another branch to work on those. To do that, we're going to use a shortcut by simply doing git checkout -b admin. The -b over there creates a branch and then checks it out. Now we'll do a bunch of changes, like create a dashboard.html file, add it to the stage and commit it, add a users.html file and commit it also. And as you can see on this graphic over here, every time we do a commit, our head moves with it. So there we are working on the admin branch, and we get a late night text message from our boss saying, "Ooh, there are bugs on master, you need to fix them." So we have to stop what we're doing, git checkout master. We can run git branch to make sure that we are actually on master. And then we're going to pull from the remote repository to make sure that we have the latest changes. Then we're going to do our fixes by fixing the star.rb and product.rb files. And finally, we're going to push those changes back up to the master remote. Now that the emergency has been taken care of, it's time to move back to our feature branch. So we go git checkout admin. So we finish off our changes, git checkout master when we're ready to merge things back into master, and git merge admin. And suddenly, you're in a weird editor. Don't panic, this is VI. You may have seen this before, but just in case, here are commands at the bottom of the screen to navigate around VI. It's simply Git asking you, okay, I made this commit message for you because I've seen what you're trying to do. You're trying to merge those two branches. But if you need to be more explicit, please add to this message at the top. As you can see, it wrote merge branch admin. You can modify this message if you want to, and then when you're done, type :W for write and Q for quit to go back to your command line. Since we merged two branches with two sets of changes, Git had to do a recursive merge. When that happens, Git creates a commit right there when the branches are melded back together. If you look at your log, you will see that that merge commit was actually created in the log. It doesn't contain any files, but it simply says, at this point, master and admin became one branch. Thanks for watching Level 3. Now it's time for you to go play with branches and merging in the challenges.